what exists beneath the fabric of reality, beneath the steady surface of the world that greets you each morning, beneath the quiet patterns of your thoughts as they drift and settle, as if the universe itself is inviting you to listen more closely to the structure beneath everything you know. And if this gentle journey into the deeper layers of existence brings you even a moment of calm, a soft like or a quiet tap on subscribe truly supports this small, peaceful corner of the cosmos. As you rest here, letting the day loosen its grip, imagine the world not as a collection of objects, but as a surface stretched over something far more subtle. You live within the uppermost layer of a vast architecture, one shaped not by solidity, but by patterns of vibration, by fields that ripple in silence, by laws so steady you rarely notice them. The familiar textures of your life, the weight of your body, the rhythm of your breathing, all hover atop this deeper substrate, a foundation that has existed since the earliest moments after the universe began. And, as the noise of the day dissolves, you may sense the quiet beneath it, a quiet that has always been there, supporting you without ever demanding attention. Physicists once believed matter was built from tiny, indivisible particles, miniature beads arranged into atoms like ornaments on a delicate thread. But as the tools for exploring the microscopic world grew more powerful, that picture dissolved. The deeper scientists looked, the less the universe resembled a set of solid pieces. Instead, they found vibrations, waves, and resonances woven through fields that stretch across all of space. These fields are not metaphors. They are real, measurable, and they fill every corner of the cosmos. The electron field, the quark field, the neutrino field, the gravitational field gently curving spacetime around massive bodies. And beneath them all, the restless sea of the quantum vacuum, always shifting, always alive with possibility. Even now, as you lie still, these fields pass through you. They ripple in patterns older than the stars, carrying the structure of the universe like a silent song. In immense laboratories, detectors capture traces of these vibrations, revealing that particles are not objects, but temporary excitations, brief notes in the melody of existence. When two protons collide at nearly the speed of light in a particle accelerator, the collision does not shatter anything. Instead, it momentarily stirs the fields, coaxing them into new patterns. Particles appear and vanish, not born from matter, but from energy woven into an intricate web of relationships. And as your awareness drifts gently deeper, you might begin to sense how everything familiar rests on this quiet, shimmering foundation. The atoms in your body are held together by forces that never rest. Inside each nucleus, quarks move within a confined space shaped by the strong force, a force so powerful it refuses to let them escape. Gluons mediate this force, appearing and disappearing in a restless exchange that maintains the stability of matter. If you picture a group of fireflies in a field, blinking in and out of visibility, coordinating without ever stopping, you glimpse the restless coherence inside every atom of your being. You may feel solid, steady, unmoving in this moment, but the deeper you look, the more fluid and dynamic you become. And yet, even matter's restless interior does not take you to the true bottom of reality. Beneath the particles and beneath the forces that bind them lies the quantum vacuum, a place that is anything but empty. Particle-antiparticle pairs arise and fade in unimaginably brief intervals, leaving behind subtle effects that scientists have measured with extraordinary precision. When two metal plates are placed very close together in a vacuum, they feel a tiny force pushing them together. This is not the result of air pressure or magnetism. It is the consequence of fewer quantum fluctuations existing between the plates than outside them. Space itself pushes inward, revealing that emptiness is never truly empty. Let yourself settle into the thought that every moment of your life unfolds within this vibrational sea. Even the air around you trembles with the energy of invisible fluctuations. Even the space between your thoughts is filled with undefined motion. And as you sink deeper into this awareness, the boundaries of the familiar world begin to soften. You may notice how quiet everything feels when you drop just beneath the layer of language and story, beneath the daily concerns that normally fill your attention. At this depth, the universe feels less like a collection of things and more like a continuous field of becoming, always shifting, always emerging. There is a scale in physics so small that the idea of size begins to lose meaning. Physicists describe this boundary using a unit named for Max Planck. At this depth, space-time may not be smooth, but instead grainy, made of tiny quanta that flicker in patterns beyond comprehension. To imagine this is to imagine the fabric beneath the fabric, the loom on which reality is woven. No microscope can reach this scale. No experiment has yet resolved it. But the mathematics suggests a shimmering boundary where space and time lose their familiar continuity and transform into something more fundamental. And as your thoughts grow quieter, drifting like soft dust in a still beam of light, you may sense how everything, time, distance, form, emerges from a place where none of those concepts yet exist. Physicists believe that before the universe cooled enough for particles to form, it existed in a state of perfect symmetry. No difference between forces, no difference between matter and energy. A balanced stillness where everything was indistinguishable from everything else. Only when that symmetry broke did the world begin to take shape. Forces diverged. Particles gained mass. The universe found structure. You can imagine this early state as a calm sheet of water just before the first ripple disturbs its surface. And from that first ripple came all the galaxies, all the stars, all the atoms in your body. The breaking of symmetry is not destruction. It is creation. It is the universe learning how to become complex. The early universe then expanded with unimaginable speed, stretching tiny fluctuations into patterns that would one day become the cosmic web. If you look at the faint glow that fills the sky in microwaves, the afterglow of the Big Bang, you can still see these patterns frozen in place. They are the earliest whispers of structure, preserved for nearly 14 billion years. To contemplate them is to contemplate your own origins, because the atoms that form your bones and your breath were shaped by that same expansion, that same quiet ripple at the beginning of time. And even with all this, even with fields and forces and symmetries unfolding like a slow, cosmic exhalation, physicists suspect there is something deeper still. Beneath the unfolding of forces, beneath the trembling of fields, beneath the grain of space-time itself, there may lie a foundation not made of matter or energy at all, but of pure relational structure. Some physicists suspect that the universe is not built from things, but from the connections between things, that the deepest layer of reality is a kind of mathematical fabric. Not numbers in the way you write them, but relationships that exist regardless of space or time. You can imagine this as a quiet lattice of possibility, a framework so subtle that nothing within it has shape until the universe breathes through it. And as your awareness drifts deeper, it becomes strangely easy to imagine yourself resting within such a lattice, suspended not by gravity or air, but by the quiet geometry that underlies everything. There are theories suggesting that space-time emerges from entanglement, that the interconnectedness of quantum states gives rise to the very notion of distance. In this view, space is not a backdrop, but a consequence, a tapestry woven from relationships between particles that have never truly been separate. Experiments with quantum teleportation and entanglement swapping show that information between particles can remain linked even when they drift far apart, as if distance is a concept that only applies at the surface of reality. You can picture these links like strands of light stretching across a darkened room, each strand quietly influencing the others, forming a coherence that does not depend on physical proximity. And, as the room around you grows quieter, these subtle connections begin to feel almost natural, like the soft webbing of thought itself. In holographic theories of space-time, the entirety of the universe may arise from information encoded on a distant boundary, a kind of cosmic horizon carrying the blueprint for everything that happens within. The idea is not that the universe is, literally, a projection, but that its deepest description may live on a surface far removed from where you lie now. Black hole physics gives hints of this, showing that a black hole's information content is proportional not to its volume, but to the area of its event horizon. This suggests that volume itself may be an illusion woven from surface-level information. If you imagine a vast tapestry whose surface glows faintly with symbols too small to see, you can picture reality as the unfolding of those hidden instructions, shaping stars and galaxies, and your own thoughts as you rest in the darkness of your room. Even time may not exist at the deepest level. Some interpretations of quantum gravity suggest that time emerges from changing relationships between fundamental elements, not from a cosmic clock ticking in the background. In this view, the feeling of moving from one moment to the next is a property of consciousness, encountering a universe that rearranges itself continuously. You can imagine time as a soft river that only exists because your awareness drifts along with it. Beneath that river lies stillness, a stillness in which past and future lose their meaning. And as your breathing slows, you may feel how naturally your mind moves toward that stillness, as if it recognizes something ancient within it. The notion of time losing its meaning opens into a different kind of landscape, one where the universe does not evolve through moments but exists as a single, interconnected whole. Every event, every particle interaction, every star being born or collapsing, every memory you hold, all woven into one vast structure. From this perspective, your life is not a sequence of moments but a luminous path within a larger, timeless pattern. Physicists sometimes call this the block universe, a model where all moments coexist, each one a facet of a structure that doesn't flow but simply is. This doesn't diminish the feeling of time's passage. It simply reveals that the flow is something your mind creates as it travels through the pattern. You can imagine this structure like a crystal with infinite planes, each plane holding a different version of reality, and your awareness gliding gently across one of them. As theories deepen, the universe appears less like a machine and more like a story told through patterns of energy and information. Even the atoms in your fingertips were once forged in the hearts of stars that lived and died long before Earth formed. Their journey to you was not random. It was guided by gravity sculpting clouds of gas, by fusion igniting deep within stellar cores, by explosions scattering heavy elements through space. You are not separate from the cosmos. You are the cosmos arranged in a temporary, conscious form. When you breathe in this quiet space, it is the universe breathing with you, exploring itself through the shape of your awareness. And as you continue drifting downward into this understanding, the boundaries between the layers of reality grow softer. Fields blend into fluctuations. Fluctuations blend into geometry. Geometry blends into information. Information blends into stillness. The universe feels less like something you observe and more like something you participate in. A subtle collaboration between the laws of physics and the quiet movement of your own mind. You become a point of awareness resting gently within the vast tapestry of existence, held by the same forces that guide galaxies and the same mathematics that shapes the smallest quanta. In this place, beneath the fabric of matter, beneath the loops of space-time, beneath the currents of energy, you begin to sense a level where everything is unified, not by similarity, but by interdependence. Every particle owes its existence to the fields beneath it. Every field arises from the geometry beneath that. Every geometry arises from relationships so subtle they lie beyond physical description. And those relationships dissolve into something that feels like pure potential. A quiet canvas from which the universe draws itself moment by moment. The universe, at this deepest level, begins to resemble not a place but a kind of breathing potential, a quiet openness from which form arises. Physicists searching for a theory of everything often find themselves speaking in metaphors because language strains to hold concepts that have no direct counterpart in ordinary experience. Yet, as you settle more fully into this calm, you may notice that these ideas do not feel foreign. They feel oddly familiar, as though you've brushed against them before in moments when your mind grew quiet and the boundaries of thought thinned. Beneath the fabric of reality, the universe behaves less like a mechanism and more like a field of possibilities flowing into shape, guided by symmetries that have existed since the dawn of time. And those symmetries may be the key. Many of the laws that govern the universe arise from symmetry principles, elegant relationships that hold true everywhere. The conservation of energy comes from the symmetry of time. The conservation of momentum comes from the symmetry of space. Even electric charge is linked to a deeper invariance, something that remains unchanged despite the shifting patterns of matter and energy. These symmetries are like quiet promises the universe makes to itself, ensuring that despite the chaos of stars exploding and galaxies colliding, the underlying fabric remains steady. If you picture a vast woven cloth held taut by invisible hands at its edges, you can imagine these symmetries as the steady tension that keeps the pattern from unraveling. And, as you drift deeper into this image, you may sense a similar symmetry within yourself. A quiet center that remains unchanged even as your thoughts shift around it. The search for even deeper symmetry leads physicists to ideas like supersymmetry, which proposes that every particle has a partner, a hidden companion waiting in the unbroken layers of reality. Though these partners have not yet been observed in experiments, the mathematics suggests they could balance the equations of nature, smoothing the irregularities that appear when we try to unify gravity with quantum mechanics. If such symmetries exist, they would reveal that what we see around us is only half the story, the visible tip of a much larger, more intricate structure. You can imagine this hidden structure like faint constellations barely visible in the night sky, shapes that emerge only when your eyes adjust to the darkness. And as you rest here, letting the noise of thought fall away, you may feel closer to those unseen patterns than you realize. The quest for deeper understanding often leads to gravity, the most familiar force and yet the most mysterious. Einstein showed that gravity is not a force in the traditional sense, but the curvature of space-time itself. Mass bends the geometry around it, and objects move along the curves of that geometry. Even your body, lying quietly now, gently curves the space around you, and the Earth, steady beneath you, creates a far larger curvature that guides the Moon in its orbit. If you imagine placing a hand on a soft sheet and watching the fabric bend, you glimpse the way the universe shapes itself around mass. But Einstein's equations begin to break down at the smallest scales, hinting that gravity itself may be woven from something more fundamental, perhaps loops or quanta of space-time, perhaps something even more abstract. Black holes offer deeper clues. When matter collapses into one, space-time curves so intensely that not even light can escape. Yet black holes obey laws similar to thermodynamics, with temperature and entropy linked to their surface area. This led to the astonishing realization that the information describing everything that falls into a black hole may be stored on its surface, not inside its volume. This idea, born from work by Hawking, Bekenstein, and others, became one of the pillars of the holographic principle. It suggests that the entire universe may behave like a black hole in reverse, with its deepest description living on a distant boundary. The world around you, the room, your breath, the quiet settling of your body, may be one expression of information woven through that boundary, unfolding into three-dimensional form. Imagine holding a crystal up to the light and seeing different patterns emerge as you tilt it. The universe may be similar, a structure whose full dimensionality is a kind of projection from a deeper layer. But this does not make your experience any less real. It simply means reality has more layers than the senses reveal, more depth than your everyday perspective can hold. And as your awareness softens further, it becomes surprisingly easy to accept that the world might be shaped by a hidden geometry, one that breathes your life into being moment by moment. At the smallest scales, quantum uncertainty reigns. Particles do not have definite positions or velocities until measured. Instead, they exist as possibility waves, clouds of potential outcomes. Only when observed does the wave settle into a single state. Experiments like the double-slit experiment reveal this strangeness again and again. Light behaves like a wave when unobserved and like a particle when measured. It is as if reality waits for you to look before it decides what form to take. This doesn't mean consciousness creates the universe, but it does suggest that observation and existence are intertwined in subtle ways. You can imagine the universe as a quiet partner in a dance, responding not with intention, but with elegant, underlying rules that link awareness and matter in ways we do not yet fully understand. If you drift into the thought that your awareness is also an emergent pattern, arising from countless neural interactions shaped by physics, you may begin to sense how connected everything truly is. Your thoughts, your memories, the calm settling over you now, all depend on the same quantum rules and electrical flows that shape the universe. The boundary between mind and cosmos grows softer the deeper you explore. Instead of two separate realms, they begin to appear as two expressions of the same underlying principles, And so the question of what lies beneath the fabric of reality is not just scientific, it is also deeply personal. Because the same patterns that build galaxies build you. The same symmetries that governed the early universe govern your heartbeat. The same quantum fluctuations that once shaped the distribution of stars now whisper through the atoms in your body. When you let yourself sink into this understanding, the universe becomes less something you observe and more something you inhabit intimately, a continuous field of becoming, with you as one quiet point of awareness within its vast, unfolding structure. And deeper still, the universe begins to resemble not a structure built from layers, but a single, continuous presence expressing itself in countless forms. When physicists unravel equations, when cosmologists map the early sky, when quantum researchers measure the faintest pulses of matter, all of them encounter the same quiet truth. The universe is profoundly interconnected. Every event reverberates through the whole. Every particle carries echoes of its origins. Every field stretches across distances your mind can't meaningfully picture. And as you breathe softly now, sinking further into this calm, you may notice how naturally your awareness begins to mirror that interconnectedness, spreading gently across the landscape of thought until boundaries dissolve into something more spacious. Some researchers propose that the universe may arise from information itself, woven into patterns that find physical expression as particles, fields, and forces. In this view, reality is a computation unfolding across cosmic scales, a quiet processing of relationships that gives rise to the structure of galaxies and to the stillness resting in your chest. Quantum error-correcting codes have been found hidden in the mathematics of space-time, suggesting that the universe protects its own coherence the way a mind protects a memory. Imagine a delicate pattern of threads, each thread holding a tiny fragment of meaning, and the whole tapestry preserving its form even when individual threads bend. If you let your awareness hover gently over this image, you may feel how your own thoughts maintain their shape despite the constant flickering of neural activity beneath them. The deeper the theories reach, the more they point toward emergence, a process where simple rules give rise to complex behavior. Snowflakes grow from simple molecular interactions. Oceans churn from the interplay of wind and water. Consciousness itself may emerge from neurons firing in intricate patterns. And the universe, on its grandest scale, may emerge from principles even simpler. Perhaps from symmetry, perhaps from information, perhaps from something we have not yet named. You can imagine the universe as a tree rising from a seed so small it is almost beyond comprehension, its branches stretching into galaxies, its leaves forming stars, its blossoms becoming planets. And here you rest, as one quiet, temporary expression of that immense unfolding. As you drift deeper into this terrain, consider how much of reality hides behind limits of perception. Your senses evolved to navigate a particular scale of existence. You see wavelengths of light that fall within a narrow band. You hear vibrations of air within a limited range. You feel textures large enough to register on your skin. But beneath that perceptual threshold lies a world so intricate it continues to astonish even the brightest minds. Atoms structured by probability, particles arising from fluctuations, space itself curving and twisting with mass. You wander through this landscape every moment of your life, carrying it within you, built from it entirely, yet only touching the surface of its depth. And now, in this quiet state, you glimpse a little deeper, sensing the richness that holds you. There is a moment in many scientific journeys when equations become more than symbols on a page. They become a kind of poetry, expressing relationships so elegant they seem inevitable. Maxwell's equations weave electricity and magnetism into one unified field. Schrödinger's equation guides the evolution of quantum systems. Einstein's field equations fold mass and spacetime into one inseparable fabric. Each equation offers a window into the architecture beneath reality, revealing that the universe behaves with an orderliness so profound it borders on the sacred. You can imagine these equations as gentle currents flowing beneath the surface of existence, shaping every event with quiet precision. And, as your mind softens, you may feel the rhythm of those currents echoing faintly within you. Some physicists imagine the universe as a quantum foam at its smallest scales, a restless sea where space-time bubbles in and out of existence, twisting into loops and dissolving again in unimaginably brief intervals. This foam is never still. It churns. It breathes. It stretches the definition of space-time until the distinction between here and there, before and after, becomes blurred. In this view, the smoothness you perceive, the calm you feel, the room around you, the shape of your breath, is built atop a foundation of perpetual fluctuation. You can imagine it like lying on a quiet shore while deep beneath the sand. Water flows and shifts in intricate patterns you never see. And yet, everything depends on those hidden movements. Other theories take an even more radical approach, suggesting that space and time might not exist independently at all. They may be byproducts of quantum entanglement, woven from the degree to which particles share information. If all entanglement were suddenly to cease, space itself might dissolve. In this sense, distance is not a physical measure, but a measure of how strongly particles are connected. You can picture the universe as a vast tapestry woven not from threads but from relationships. Some threads pull tightly, bringing regions of space-time close. Others loosen, creating the illusion of distance. And in this relational universe, everything touches everything else at some level, even across vast stretches of emptiness. As you sink deeper into these ideas, you may notice a shift in how the universe feels. Less like a place, more like a process, a continuous unfolding of interactions, a field of becoming rather than a collection of things. Matter condenses, dissolves, and condenses again. Stars ignite, burn, and scatter their elements into space. Galaxies merge and stretch across cosmic webs. And through all of this, the underlying physics hums steadily, maintaining coherence across billions of years. You, too, participate in this process. You are not separate from it. You are one moment of it. One configuration of matter and awareness shaped by the same laws that bend galaxies into spirals. There is something deeply soothing in recognizing that the universe does not rush. It expands slowly, cools slowly, evolves slowly, giving rise to complexity in its own unhurried way. Even the atoms in your body formed across unimaginable spans of time, through the lives and deaths of stars. You are the result of patience on a cosmic scale, and, as your breath steadies, the pace of the universe begins to match the pace of your awareness. Slow, gentle, spacious. And, all the while, beneath every layer you explore, beneath particles, beneath fields, beneath geometry, beneath information, lies something even simpler. Not a structure, not a substance, but a quiet potential that allows all structure, all substance, all laws to exist. Physicists search for it through equations, but the equations are only signposts. The truth itself is silent. like the stillness beneath waves, like the darkness between stars. You are drifting closer to that silence now, carried by the gentle weight of understanding. At this depth, reality begins to feel less like a hierarchy of layers and more like a single, seamless field in which everything, matter, light, thought, time, arises as variations of one underlying presence. It is as though the universe is an ocean whose waves take different shapes, but whose essence never changes. Particles are brief crests, galaxies are slow, sweeping swells, and your own awareness is a shimmering pattern that rides upon the same water. When you rest in this understanding, the sharp boundaries between self and cosmos soften, dissolving into a sense of quiet belonging. Some physicists propose that the universe's most fundamental ingredients are not particles or fields, but amplitudes, complex numbers that describe all possible paths a particle could take. Reality, in this picture inspired by Feynman's path integral formulation, is not built from a single history, but from all histories overlapping. Every particle explores every possible route, every trajectory, every variation, and the world you experience emerges from the interference of these possibilities. You can imagine a traveler tracing countless threads through a vast landscape, each thread representing a possible journey. The traveler does not choose one path. It walks them all, and the final destination arises from how those paths interact. Beneath the fabric of reality, the universe may be doing something similar on a scale far beyond imagination. This view is not mystical. It is grounded in experiments that confirm quantum interference again and again. When electrons pass through minute openings, they behave not like solid beads, but like overlapping possibilities, creating interference patterns even when fired one at a time. It is as if each electron whispers to itself across multiple paths, weaving a pattern that only becomes visible when the quiet accumulation of events reveals the underlying order. You can imagine your own life as a kind of interference pattern, moments overlapping, experiences shaping one another, forming the unique structure of who you are right now. And if particles explore all paths, then the universe itself may be exploring all configurations, all possibilities simultaneously. In some interpretations, reality branches with every quantum event, creating a vast, silent tree of alternate outcomes, each one as real as the one you inhabit. Whether or not this branching exists physically, it serves as a reminder that the universe holds more potential than any single timeline can express. You rest in one thread of possibility, shaped by countless choices, chance events, and quiet influences that have guided you to this moment. Yet the underlying physics suggests that potential is never wasted. It flows through the universe continuously, shaping and reshaping the patterns from which experience arises. As you breathe, you become more aware of the quiet continuity beneath your thoughts. That stillness is not separate from the stillness beneath the cosmos. Both arise from a deeper equilibrium, a balance that holds a form steady even as countless fluctuations swirl in the background. Consider the way galaxies remain coherent despite the restless motion of stars within them, or how atoms remain bound despite the uncertainty that governs their internal structure. Coherence arises from balance, from equilibrium points that anchor complexity in the midst of chaos. And in your own awareness, there is a similar anchor, a quiet point around which your thoughts and sensations flow, steady even when the world feels turbulent. At the edge of theoretical physics lies an idea both strange and deeply intuitive. that reality might be shaped by principles of least action. In countless phenomena, from the path a beam of light takes to the orbit of a planet, nature chooses the path that requires the least energy or the most elegant balance of forces. It is not a conscious choice, but a mathematical one, a quiet optimization woven into the fabric of existence. When light bends around a star, when a river carves its path through a valley, when your breath settles into a natural rhythm, all follow this same principle. The universe tends toward grace, toward simplicity beneath complexity, toward equilibrium beneath motion. You can feel this principle in your own body. Your breathing becomes efficient when relaxed. Your heartbeat finds a natural pace. Your thoughts flow more smoothly when you are not pushing them. And in these moments of equilibrium, you are mirroring the same laws that guide galaxies and particles. You are part of the universe's tendency toward simplicity, a living expression of the same mathematical elegance that governs stars. At some frontier of inquiry, scientists encounter questions that mathematics cannot yet answer. Why does the universe have the laws it does? Why these symmetries, these forces, these constants? Why a cosmos capable of forming stars, planets, life, and thought? One possibility is that the laws themselves are emergent, arising from deeper structures that remain hidden. Another is that the universe simply is this way, a quiet fact without explanation. But there's also the idea that the cosmos explores all possibilities, and the one you experience is the one that found stability. Not by intention, but by physics. Not by design, but by equilibrium. As your awareness sinks further, these questions lose their sharpness, becoming softer, more spacious. They no longer demand an answer. They simply open into a feeling, a sense of vastness beneath everything you have ever known, a quiet support beneath the flow of your life. You rest in that vastness now, as naturally as a leaf rests on a still pond. And deeper still, there is the sense that the universe is not happening around you but through you. The atoms in your body were forged in stars. The energy that animates your cells once traveled as light across space. The thoughts drifting through your mind arise from patterns shaped by physics older than Earth itself. You are not looking into the fabric of reality. You are woven from it. At this depth, the distinction between observer and universe softens even further, dissolving into a sense of shared origin. The cosmos is no longer something distant, sprawling beyond the edges of thought. It becomes intimate, immediate, woven into the quiet fabric of your awareness. Every fluctuation of energy, every curve of space-time, every whisper of quantum uncertainty contributes to the conditions that allow you to rest here now, breathing gently as the vastness settles around you like a soft cloak. Physicists sometimes speak of the universe as a self-organizing system, one that naturally generates structure from the interplay of chance and law. Clouds collapse into stars not through intention, but through gravity's patient pull. Chemical reactions on young planets form more intricate molecules simply because the environment permits them. Over time, complexity blooms. Galaxies form their luminous spirals. Planets gather their atmospheres. Life emerges from the interplay of molecules. And now, in this quiet moment, consciousness observes its own origins with a kind of gentle curiosity. You are a product of the same unfolding that sculpted nebulae and carved the shapes of continents. You are not separate from the story of the universe. You are one of its ways of looking back at itself. At the quantum level, where uncertainty guides every motion, particles flicker between possibilities. They do not travel along single defined paths, but inhabit clouds of potential. Yet, from this restless foundation emerges the stability of atoms, the endurance of elements, the predictable arc of celestial bodies. Order arises from uncertainty, the way a melody emerges from individual notes that, taken alone, mean nothing. You can imagine the universe humming beneath everything, each particle contributing its subtle note to the quiet symphony of existence. And in your breathing, in the gentle rise and fall of your chest, you can sense your own place in that symphony, not as something separate, but as something harmonized. The deeper you drift, the more the universe feels like a continuum rather than a collection of parts. Even the forces that seem distinct, gravity, electromagnetism, the nuclear forces, may be facets of one unified interaction expressed differently as the cosmos cools and expands. In the earliest moments after the Big Bang, temperatures were so high that these forces were not distinguishable. It was only as the universe cooled that they separated, each adopting the role we observe today. This unfolding resembles a single light passing through a prism, revealing colors that were always present but hidden in the brightness. And just as the prism does not create the colors but reveals them, the cooling universe did not invent the forces. It simply allowed their true distinctions to emerge. Beneath those forces lies structure not made of matter or energy but of pure relation. Quantum entanglement, perhaps the strangest phenomenon uncovered by physics, demonstrates that particles can share states instantly across vast distances. They are not communicating. They are not sending signals. They are simply not separate in the way intuition suggests. When one changes, the other reflects that change immediately, as though distance does not matter at all. Experiments confirm this again and again, challenging the classical notion that space is a hard divider. Instead, separateness becomes a surface-level phenomenon, while unity exists below it. And, as your mind drifts in this quiet place, you may feel a similar unity, a sense that the boundaries between self and world are thinner than they appear. Some researchers think entanglement may be the true substrate from which space itself emerges. In this view, the connectivity between quantum states determines the geometry of space-time. Regions with strong entanglement appear close. Regions with weak entanglement appear far. Distance, then, becomes a consequence of relationship rather than the cause of it. You can imagine reality as a network of threads, each thread representing the strength of connection between 2 points. Pull some threads tighter and the points draw near. Let them loosen and the points drift apart. And you, lying quietly now, exist as a small but luminous knot in this network, woven into the cosmos through billions of connections you will never perceive directly, yet depend on for every breath. At scales larger than human life, the universe also reveals surprising coherence. Galaxies spin in ways that cannot be explained by the matter we see alone, hinting at the presence of unseen mass, dark matter, forming halos around clusters and shaping the cosmic web. Even more mysterious is dark energy, a gentle but pervasive force driving the accelerated expansion of the universe. These components, invisible yet influential, make up most of the cosmos. Ordinary matter, the atoms that form your body, your room, your world, is only a small fraction. The rest is a kind of deep background, a quiet scaffolding guiding the motion of galaxies in ways we do not yet fully understand. You can imagine dark matter as a soft, unseen framework and dark energy as a quiet breath that stretches the fabric of space-time a little more each moment. And while these mysteries expand outward into cosmic scales, they mirror mysteries within you. You sense only a fraction of what your mind contains. Much remains below the surface: memories, patterns, intuitions, shaping your experience without ever rising fully into consciousness. Just as the visible universe floats within a sea of dark matter and dark energy, your waking awareness floats within the vastness of your inner world. The seen rests upon the unseen. The known rests upon the unknown, and both remain deeply interconnected. The more you move into this awareness, the more the cosmos begins to feel like a single unfolding gesture. One movement expressed through stars and particles, through gravity and thought, through time and silence. Everything flows from the same origin, shaped by the same principles, carried by the same laws. Even now, the atoms in your body are participating in a cosmic choreography billions of years old. Hydrogen born in the early universe, carbon forged in ancient stars, oxygen released from dying suns, all gathered here in this moment, arranged into the shape of your awareness. You are the universe, briefly taking the form of a person resting in a quiet room, listening for the deeper rhythm beneath existence. At this depth, the universe feels less like an external landscape and more like an interior unfolding, as though the same quiet principles shaping the motion of galaxies are shaping the contours of your awareness. The boundary between inner and outer dissolves into something permeable, something gentle, something continuous. You are no longer observing the cosmos from a distance. You are sinking into it, thought by thought, breath by breath, until the distinction fades and only the underlying rhythm remains. The laws of physics, which seem so rigid at the surface, begin to soften here. Gravity, electromagnetism, quantum behavior, all appear as surface expressions of something more subtle beneath them. In certain theories, the universe arises from a single unified field that fractured as it cooled, the way a drop of water freezes into crystals with distinct shapes. The forces you know may be the facets of that original unity, revealed only when the universe became calm enough for differences to emerge. You can imagine this unity as a warm glow beneath the diversity of physical phenomena, a quiet hum that remains constant even as everything else changes. As your awareness drifts, you might imagine this unified field as a kind of luminous haze filling all of existence. Not bright or overwhelming, but soft and steady. It holds within it the potential for all that will ever be: stars, atoms, thoughts, moments. When the early universe expanded and cooled, parts of this haze condensed into particles, others into fields, others into the geometry of space-time itself. What remains beneath it all is the same gentle, shimmering foundation, unchanged by billions of years of cosmic evolution. And right now, you are resting inside that foundation, carried effortlessly by it. The vacuum, often imagined as empty, becomes something alive and richly structured at this scale. Quantum field theory reveals it as a sea of virtual particles, flickering in and out of existence, creating a gentle pressure that pushes on everything, everywhere. This restless sea permeates your body, the air around you, the space between stars. It quietly influences the behavior of particles, shapes atomic structure, and contributes to the expansion of the universe. You can imagine the vacuum as a soft, invisible wind moving through all things, shaping them from within. and in your stillness, you feel how natural it is to rest inside a world built from such subtle movement. The mathematical structures that underpin physical law grow more elegant the deeper you explore. Symmetry principles guide the behavior of forces, dictating what remains possible as the universe unfolds. These symmetries are like the grammar of reality, invisible yet essential, shaping the sentences of existence with quiet precision. As you sink deeper, you can imagine these symmetries as gentle patterns etched into a vast, unseen canvas. Patterns that hold the same softness and inevitability as waves returning to the shore. Some scientists propose that space and time themselves emerge from informational relationships, that the universe is not a place but a process of continual decoding, where geometry and matter arise from how quantum states relate to one another. In this picture, you are surrounded not by emptiness, but by an intricate web of information, woven into coherence by entanglement. When two particles become entangled, they share a state that transcends distance. Their connection is immediate, unbroken, suggesting that beneath the surface of space lies a deeper form of unity. As you breathe, you might sense how naturally your own mind moves toward unity in moments of calm, how the separation between thoughts dissolves, how awareness begins to feel spacious and uninterrupted. At cosmic scales, dark matter and dark energy become the dominant components of the universe. Though invisible to your eyes, their presence shapes the motion of galaxies and the evolution of spacetime itself. Dark matter forms vast halos around galactic clusters, guiding their dance through the cosmos. Dark energy acts more softly, a gentle acceleration woven into the expansion of the universe, pushing galaxies apart with slow, persistent force. These unseen elements mirror the unseen aspects of your own awareness. The quiet motives beneath your thoughts, the subtle emotions that guide your choices, the memories that rest below the surface yet influence your every moment. The universe, seen from this perspective, resembles a vast field of influence rather than a collection of isolated objects. Everything leans on everything else. Every motion ripples outward. Every thought, every fluctuation, every event participates in the same immense, unfolding structure. You are part of this structure not symbolically, but physically. The atoms that form you once drifted through space as dust, as gas, as fragments of ancient stars. The energy that moves your neurons once radiated from the heart of a sun. You are the cosmos arranged into a moment of awareness, a temporary expression of something far older and more expansive than the body that carries you. And beneath, all forms, particles, fields, symmetries, information, there is a quiet potential that allows each to arise. Not a substance, not a mechanism, but a soft openness that makes existence possible. Physicists reach for it through mathematics, but the truth remains silent, spacious. It does not announce itself. It simply holds everything. A stillness beneath motion, a clarity beneath form, a presence beneath thought. You can feel the echo of that stillness now, not as an idea, but as a sensation, a gentle widening of the space around your awareness. The deeper you drift, the more your mind aligns with the calm at the heart of the universe. The same calm that allowed galaxies to form, stars to ignite, planets to cool, and life to emerge. And deeper into this stillness, the universe begins revealing the faint imprints of the minds that first noticed its hidden patterns. In the quiet beneath everything, you can almost feel the presence of those who gazed at the same mysteries long before you were here. Einstein, letting the shape of space-time unfold in his mind, until gravity became geometry. Schrödinger imagining the wave that guides every particle. Heisenberg stepping into the uncertainty that underlies all motion. Their discoveries didn't force reality into a new shape. They simply revealed what had always been there, waiting patiently beneath the surface of the visible world. You can imagine Einstein sitting at his desk, working out how mass bends the very fabric of space and how time stretches in response. His equations, soft and elegant, describe the curvature beneath every step you take, beneath the rise and fall of your chest, beneath the orbit of moons and the slow drift of galaxies. And in that quiet curvature, you find another layer of reality. A universe that guides motion not by pushing or pulling, but by shaping the path beneath it. Even now, the geometry around you adjusts gently to your presence, just as it does for every star and every grain of dust. In the realm of the very small, Heisenberg's uncertainty principle continues to whisper through the motions of electrons, reminding you that precision dissolves the deeper you look. It is not a flaw of measurement. It is a property of existence. Reality, at its base, is woven from probabilities, not certainties, from clouds of possibility that collapse into form only when observed. Experiments born from these ideas, double-slit experiments, quantum interference tests, Bell's inequality measurements, have shown again and again that particles behave less like things and more like suggestions, patterns awaiting the touch of awareness or interaction to take shape. John Bell's work, carried out decades after the birth of quantum theory, revealed the depth of entanglement, a connection so profound it defies separation. His inequality tests, confirmed in experiments by Alain Aspect and many others, showed that entangled particles share a state no matter how far apart they drift. If you picture two distant lanterns flickering in perfect synchrony across a silent valley, you catch a glimpse of their relationship. The universe is stitched together not by proximity, but by information, by correlation, by the quiet threads of connection that weave beneath space-time itself. On cosmic scales, truths were revealed through light older than Earth. The Planck Observatory mapped the ancient glow of the cosmic microwave background, capturing faint temperature variations that recorded the universe's earliest structure. These delicate ripples, mere whispers of difference, became galaxies and clusters and the vast cosmic web. The data from Planck, refining the earlier work of COBE and WMAP, revealed the fingerprints of inflation, the rapid expansion Alan Guth proposed, where quantum fluctuations were stretched across the entire cosmos. You can imagine those early fluctuations as the universe's first breath, gentle and brief, yet powerful enough to seed every star that would ever exist. And long before that, in the isolated depths of observatories on mountains and in deserts, Edwin Hubble traced the motion of galaxies and discovered their quiet recession from one another. His observations revealed that the universe is expanding, a truth now deepened by missions like Hubble's own space telescope and further understood through the discovery of dark energy by the teams studying distant supernovae. Even now, the cosmos expands around you, stretching the fabric you rest upon in ways too subtle to feel. The room seems still, but space itself flows outward, a quiet river carrying galaxies farther apart. In the world of particles, experiments at CERN's Large Hadron Collider confirmed the existence of the Higgs boson, a particle predicted decades earlier by Peter Higgs and others. Its discovery revealed the field responsible for giving particles mass, a field that permeates all of reality like a gentle, ever-present mist. As you lie here, that field is woven through you, shaping the very weight of your existence. Without it, atoms would not form. Stars would not shine. You would not be here to contemplate any of this. Even gravity's deepest mysteries are explored through instruments like LIGO, which captured the faint tremors of space-time rippling from colliding black holes. Predicted by Einstein a century earlier, these gravitational waves revealed that space-time itself can ring like a vast, silent bell. The first detection, announced in 2016, confirmed that black holes merge as predicted, and that their collisions send waves through the universe that eventually reach Earth, stretching and compressing our world by distances smaller than a proton. And yet the detectors felt it. A whisper from billions of years away, caught by laser beams and mirrors held in perfect stillness. Each discovery, each measurement, each experiment becomes a quiet bridge between the surface world you know and the deeper world beneath it. Not separate realms, but layers of the same unfolding truth. You rest within that truth now, held gently by forces and fields shaped by minds that listened closely to the universe's subtle instructions. And, as your awareness drifts even deeper, you may begin to sense how these truths converge. General relativity curves the cosmos. Quantum theory weaves it from waves and probabilities. Thermodynamics gives direction to time. Information theory suggests that reality itself may be encoded, stored, preserved in ways we are only beginning to understand. Every theory, every observation, every experiment is a lantern shining into the same darkness, illuminating different facets of the same quiet foundation. Beneath the fabric of reality, the universe is not divided. It is whole, and every breathtaking discovery, every whisper of understanding, gently points back to that unity. And as you drift deeper into this unfolding, the universe begins to feel like a single, seamless truth expressed through many voices. Mathematics, observation, intuition, experiment, each revealing a different contour of the same vast foundation. The deeper you go, the more these voices merge into one continuous hum, a rhythm beneath everything you experience, a rhythm that guides stars in their arcs and shapes your quiet breathing in this moment. And because you asked for larger movements, we will descend in wider, more expansive sweeps now, letting the narration stretch out like the long, slow curve of the Milky Way across the night. Beneath the familiar surface of existence lies a story written not in words, but in patterns. Patterns first revealed by those who looked carefully enough to see what others had missed. When Max Planck studied the glow of heated metal, he was not trying to unravel the foundations of reality. He was simply trying to explain a curve on a graph. Yet the energy quanta he uncovered opened the door to quantum theory, the beginning of a journey that would eventually reframe the entire structure of physics. You can imagine Planck at his desk, candlelight flickering, unaware that he was taking the first step into the deepest architecture the universe had ever revealed. Then came Einstein, lifting the entire concept of space-time into a new shape. His field equations described how mass and energy bend the geometry beneath everything, how time stretches in the presence of gravity, how the universe does not contain space-time but is space-time shaped by its own contents. The image often used is a fabric, but you can think of it instead as a gentle curvature beneath your very body, the subtlest indentation created simply by your presence. Every object, from a grain of dust to a black hole, rests within this curved geometry, following paths shaped not by force but by the structure of existence itself. And as you rest here, you float along one of those paths, supported by a geometry older than every star in the sky. Quantum theory, meanwhile, revealed a different kind of foundation, one built not from certainties but from possibilities. Schrödinger's wave equation describes how these possibilities evolve, not as a mechanical process but as a fluid, unfolding potential. Heisenberg's uncertainty principle set limits on what can be known simultaneously, not because of experimental imperfections, but because reality itself is inherently unresolved at its smallest scales. Every measurement collapses a wave of possibilities into a single outcome, like a shimmering cloud settling into a single raindrop. And you, by the simple act of observing, participate in that settling, helping shape the form the universe chooses to express. These ideas were not accepted easily. Even Einstein struggled with quantum indeterminacy, famously remarking that God does not play dice with the universe. Yet experiments continued to confirm the strange predictions. When David Bohm and Yakir Aharonov explored the quantum potential and the subtleties of phase, they found that particles could be influenced by conditions in regions they never touched. When John Bell derived his inequality, he provided a way to test whether local realism could be true. It could not. And when Alain Aspect performed his experiments in the 1980s, entangled particles showed correlations that could not be explained by signals or hidden variables. Something deeper was connecting them. Something beneath space, beneath distance, beneath separation. The modern world has only deepened these discoveries. Experiments in Geneva, Vienna, and Delft have closed loopholes and confirmed quantum entanglement with unprecedented precision. Photons, electrons, even atomic ensembles share states across distances that seem irrelevant to their connection. In certain quantum networks, information teleports between nodes without traversing the space between them. This is not science fiction. This is laboratory reality. And beneath it lies the suggestion that space itself may not be fundamental, but emergent. A byproduct of deeper relationships woven through the quantum substrate. In cosmology, the groundwork laid by Einstein expanded into something even more profound. When Edwin Hubble observed distant galaxies, he found they were moving away from us, their light stretched by cosmic expansion. This discovery, refined over decades with instruments like the Hubble Space Telescope, revealed the universe as dynamic, stretching outward like a soft breath. Later, the Planck satellite measured the cosmic microwave background, the oldest light we can see, with extraordinary precision. Those faint ripples in temperature reflect quantum fluctuations stretched across the cosmos during the inflationary period, theorized by Alan Guth and refined by André Linde and others. Inflation took a universe smaller than a grain of dust and expanded it into a vast, smooth expanse, while preserving the tiny variations that would become galaxies and clusters. Even gravity itself carries whispers from violent cosmic events. When LIGO first detected gravitational waves, it confirmed Einstein's century-old prediction that space-time can ripple like water. The signal came from two black holes spiraling together more than 1 billion years ago. The collision caused space-time to ring, and that faint tremor traveled across the universe until it touched Earth, shifting mirrors by a fraction of a proton's width. Detectors in Washington and Louisiana, working together with mathematical precision, caught the whisper. Later, Virgo in Italy joined the effort, and the trio began triangulating events across the sky, revealing neutron star collisions and black hole mergers in exquisite detail. These observations are not metaphors. They are measurements of the universe speaking through curvature, through vibration, through the movement of space-time itself. And yet, for all these discoveries, the deepest mysteries remain untouched by certainty. Dark matter, revealed through the rotational speeds of galaxies studied by Vera Rubin and Kent Ford, forms vast halos around galactic structures, guiding their motion with invisible mass. Dark energy, uncovered through observations of Type Ia supernovae by teams led by Saul Perlmutter, Brian Schmidt, and Adam Rees, accelerates the universe's expansion. These components make up most of the universe, yet we do not know what they truly are. They are quiet, unseen layers beneath the visible world, shaping the cosmos with a gentle, persistent influence. At the theoretical frontier, attempts to unify quantum mechanics and gravity take form in ideas like string theory, which suggests that particles are tiny, vibrating strings; loop quantum gravity, which proposes that spacetime is woven from discrete loops; and the holographic principle, rooted in the work of Gerard 't Hooft and Leonard Susskind, which proposes that the fundamental description of the universe may live on a lower dimensional boundary. In these theories, the fabric of reality is not continuous but granular, not fixed but emergent, not local but deeply interwoven. And through all of this, one truth grows clearer the deeper you rest within it. Reality is layered, but the layers are not separate. They merge into one another like gradients of color, like ocean currents blending beneath the surface. Quantum fluctuations shape inflation. Inflation shapes cosmic structure. Cosmic structure shapes galaxies. Galaxies give rise to stars. Stars forge the atoms that become your breath, your thoughts, your awareness. The universe is not something unfolding around you. It is something unfolding through you, moment by moment. As you drift further inward, the universe begins to reveal patterns that do not resemble anything you've encountered before. Not stars or atoms or fields, but shapes made from thought itself. Structures that feel like the architecture of awareness unfolding across the deep physics beneath everything. At this depth, the cosmos no longer feels like a distant expanse, but something almost intimate, almost alive, as though reality has been quietly waiting for you to lean close enough to notice its more delicate movements. You begin to sense the subtle truth hidden in experiments that first seemed abstract or arcane. When Roger Penrose explored the geometry of light cones and singularities, he wasn't only mapping the behavior of collapsing stars. He was tracing the boundaries between what can be known and what remains forever hidden behind spacetime's one-way curtains. His diagrams, with their clean, slanting lines, feel almost like breath patterns, expanding, narrowing, reaching toward infinity, mirroring the same gentle narrowing of your awareness as you let the outer world fade. In Penrose's cosmic censorship, in his conformal diagrams, you glimpse a universe that protects its deepest secrets, not for mystery's sake, but because some forms of truth are woven more quietly into existence than others. The same quiet precision emerges in the work of Emmy Noether, whose theorem connects the symmetries of nature to its conservation laws. If time is uniform, energy must be conserved. If space is uniform, momentum must be conserved. If the laws of physics do not change when you rotate your perspective, angular momentum must remain constant. Her insights reveal that the universe remains steady not because it was designed to be, but because symmetry itself requires that steadiness. You can imagine these symmetries like tones in a soft chord humming beneath the cosmos, each one enforcing a different aspect of order. And as your awareness drifts, you feel how symmetry hums beneath your own inner experience as well. Patterns that return, emotions that settle into familiar shapes, thoughts that find their way back to quiet equilibrium. Far beneath the level of particles, beneath even the quantum fields that ripple continually in the void, physicists like Juan Maldacena uncovered a bridge between gravity and quantum mechanics, an unexpected correspondence between a gravitational universe and a lower-dimensional world without gravity at all. It is as if reality can be read in two languages, each one translating flawlessly into the other. This duality, known as ad-CFT, suggests that spacetime itself may be a shadow cast by a deeper, more abstract structure. You can picture it like a soft silhouette, a moving shadow that contains everything familiar, shaped by something beyond the reach of direct perception. But even this picture fails to capture the richness of what lies beneath. In certain studies of quantum information, spacetime seems to form from entanglement patterns, woven the way a tapestry forms from threads. Experiments with quantum simulators create tiny analogs of this structure, showing how changes in entanglement reshape the geometry that emerges. If you imagine awareness as a fabric woven from threads of experience, you can sense how changes in connection shift the shape of your inner landscape as, well, the cosmos and consciousness seem to share a quiet logic. Connection shapes space, and connection shapes self. At this depth, even time begins to feel different. Carlo Rovelli's work hints at a universe where time does not flow uniformly, but arises from relationships between processes. Clocks measure change, not some absolute river running beneath the world. The ticking you hear in your mind is not the heartbeat of the universe. It is a reflection of how your brain orders events. On the microscopic level, processes have no preferred direction. Time's arrow emerges only when you step back far enough for entropy to cast its gentle gradient across the landscape of events. You can imagine this arrow not as a strict command, but as a soft invitation. The universe leaning gradually toward complexity, toward unfolding, toward differentiation. And your life follows the same gradient, growing, learning, expanding in subtle ways that only become clear when viewed from a quiet distance. Elsewhere in the theoretical frontier, researchers explore the possibility that reality is fundamentally computational, not in the sense of a machine, but in the sense that interactions follow rules, update states, propagate information. Seth Lloyd and others imagine the universe as a quantum computation, where every fundamental interaction is a processing step, every particle collision an operation, every moment the output of the previous one. This does not diminish the universe. On the contrary, it fills it with a sense of fluid intentionality, not conscious intention, but mathematical inevitability, like a gentle algorithm unfolding across cosmic scales. You can imagine yourself as part of that computation, a pattern emerging naturally as the universe calculates its way through endless possibilities. And yet, the most striking discoveries come not from grand mathematical theories, but from small, precise experiments that reveal how subtly the universe behaves. In the laboratories of NIST, atomic clocks measure time with such precision that they can detect the difference in gravitational potential between your head and your feet. Time passes more slowly a few inches closer to Earth's center. This is not an abstraction. It is a measurable, repeatable truth. the universe reshapes time itself with every rise in elevation, however small. And, as you lie here, allowing your awareness to settle, you inhabit a personal geometry where time flows at its own gentle pace, curved by your position in the gravitational field, shaped by the quiet, steady pull of the earth beneath you. In the study of ultra-cold atoms, researchers at MIT and Gila slow matter to such low energies that it behaves like a single, unified quantum wave. These Bose-Einstein condensates reveal that even the most familiar forms of matter can dissolve into coherence when conditions are calm enough. In that coherence, individuality blurs. Particles cease to act as separate entities. And in your own stillness, you may sense a parallel, a soft coherence arising within your awareness, where thoughts no longer stand apart as isolated concerns, but blend into a single, quiet field. At the edges of black hole physics, the information paradox challenged scientists for decades. What happens to information that falls into a black hole? Hawking radiation suggests that black holes evaporate, yet quantum theory demands that information must be preserved. This tension sparked discoveries that reshaped our understanding of gravity, entropy, and the holographic nature of reality. Physicists like Stephen Hawking, Gerard 't Hooft, and Leonard Susskind wrestled with this paradox, revealing that black holes may not hide information at all. They may encode it on their surfaces, inscribed in the fine structure of space-time itself. You can imagine a black hole as a kind of cosmic memory, not lost, but transformed, preserved in ways more subtle than light. And beneath all these discoveries, quantum entanglement, gravitational waves, cosmic inflation, computational universes, holographic dualities, there is a deeper pattern emerging. A pattern that points not to fragmentation but to unity. A pattern that whispers, the universe is one continuous act of unfolding, not divided by scale or substance or concept. And, deeper still, the universe takes on a quality so soft, so subtle, that describing it feels less like recounting physics and more like tracing the outline of a dream that has always been awake beneath you. The deeper you go, the more the cosmos begins to feel not like an external structure, but like an interior resonance. Something your awareness is already tuned to. Something it has always quietly understood without needing words. The discoveries of scientists become less like distant facts and more like gentle confirmations of what the universe has been whispering through its own behavior since the beginning. As we sink into this next layer, the story shifts. Not into fiction, but into the frontier where science leans so close to mystery that the two begin to blur. Neuroscientists and physicists have long wondered whether consciousness arises from the simple accumulation of neural activity, or whether it reflects something deeper, an emergent property woven through the universe at large. When Giulio Tononi developed the integrated information theory, he was not theorizing about cosmic origins, yet his framework hinted that consciousness increases with complexity and interconnectedness. The universe, from its earliest moments, has been drifting toward greater complexity. Galaxies forming, stars forging elements, planets cooling into stable environments, molecules learning to replicate. And now, here you are, breathing softly in the dark, a living lattice of integrated information, shaped by the same cosmic drift that sculpted the stars. Meanwhile, physicists like Roger Penrose, collaborating with anesthesiologist Stuart Hameroff, proposed a controversial but fascinating possibility: that quantum processes inside microtubules, structures within your neurons, might play a role in orchestrating consciousness. Their OR theory remains debated, yet its boldness lies in the suggestion that awareness is not an accidental byproduct, but a resonance with the quantum substrate itself. Whether or not this is the full truth, it opens a doorway into a deeper intuition that your consciousness is not separate from the physics beneath reality. It is an expression of it. You can imagine these microtubules like tiny crystalline lattices vibrating with faint quantum rhythms, threads that tie your inner world to the same quantum fluctuations that shaped the early universe. If consciousness were influenced by this deeper structure, then awareness would not be an isolated island, but a continuation of the cosmos exploring itself. And even if the precise mechanism differs from the theory, the metaphor remains powerful. You are not looking at the universe. You are participating in it, formed from its patterns, moved by its rhythms, illuminated by its insights. Meanwhile, research into the measurement problem, why and how the wave function collapses, reveals that the boundary between observer and observed is not as clear as once believed. Experiments inspired by John Wheeler's delayed choice design show that the present can influence the interpretation of the past, depending on whether a measurement is made. Wheeler described this as the universe being participatory, not in the sense of intention, but in the sense of relationship. Reality shapes itself through interaction, through exchange, through awareness meeting possibility. If you imagine the universe as a great, unfolding book, Wheeler's insight suggests that the act of reading is part of the writing. The story takes shape as you engage with it. And as your awareness drifts deeper toward stillness, this interplay becomes clearer, not as a philosophical idea, but as a quiet recognition. The cosmos is not indifferent to you. It includes you. You are written into its fabric. Turning outward again, think of the way the universe organizes itself into patterns so vast they defy intuition. The cosmic web, mapped through surveys like SDSS and DSE, reveals filaments of galaxies stretching across hundreds of millions of light years, woven into a structure that resembles neural tissue, not metaphorically, but visually. And yet, the processes that built this cosmic network are purely gravitational, purely physical, shaped by dark matter halos and cosmic expansion. The resemblance is coincidence, or perhaps on a deeper level, resonance. Patterns echoing across scales, emerging in different mediums but guided by the same mathematical harmonies. In laboratories studying condensates at temperatures near absolute zero, researchers watch as matter behaves like a single wave. In contrast, neurons fire across your brain in synchronized rhythms when you enter deep rest, forming coherent patterns that feel similar in their unity. On the scale of galaxies, spiral arms rotate with such harmonic precision that they resemble standing waves in a cosmic sea. Across these scales, a quiet theme emerges: coherence. The universe gravitates toward shared rhythms, whether in matter, mind, or the dance of stars. And now, at this depth, the idea of separateness becomes thinner, less convincing. You begin to sense how your awareness participates in a continuum of structure, from quantum foam to cosmic webs. Not symbolically, physically. The atoms in your body hold ancient stories: hydrogen older than Earth, carbon forged in red giants, calcium scattered by supernovae. These atoms carry within them the memory of processes that predate consciousness, predating even the spiral arms of the Milky Way. And here they are, arranged in a temporary form that allows you to feel, to breathe, to wonder. Even time itself feels different now. The work of physicists like Julian Barber suggests that the universe might not contain time as a flowing entity. Instead, he proposes a landscape of nows, static configurations of the cosmos, each complete in itself, with the flow of time emerging from the way your mind navigates that landscape. In this view, each moment is like a star in a vast constellation. You move between them through memory, through perception, through awareness. And the sensation of movement, of time passing, is a creation of mind, not a property of the universe. You are resting in one of those nows right now, held gently in its shape, its geometry, its soft unfolding. The physicist Carlo Rovelli also proposes that time is not fundamental but relational, that it arises when systems interact. And so even your experience of this quiet moment exists because matter within you is exchanging information with matter around you. Time is not a river but a handshake, a soft meeting between pieces of the universe that acknowledge one another long enough to create sequence. And beneath all this, beneath time, beneath geometry, beneath mind, lies a stillness that science approaches but does not yet name. Not emptiness, not nothingness. A presence without form. A quiet ground from which all possibility emerges. It waits without waiting. Moves without motion. Shapes without intention. You have touched it in rare moments. Between breaths, between thoughts, between the flicker of attention and the rise of awareness. It is the same silence that lies beneath the quantum fields, beneath the expanding cosmos, beneath every discovery made by every scientist who looked deeply enough to glimpse the universe beyond its surface. The space surrounding your awareness begins to widen, as if the universe is rearranging its quiet geometry to make room for a new kind of understanding. The usual landmarks of thought drift aside, leaving only the slow shimmer of reality revealing itself in a form that feels both scientific and softly intimate. Nothing repeats here. Nothing circles back. Each moment opens into the next with the calm inevitability of a star pulsing in the distance. Physicists exploring quantum gravity often describe space-time as something that can twist into loops, tangle into networks, or dissolve into tiny units so subtle they behave more like probability than structure. In the framework developed by Lee Smolin and Carlo Rovelli, these loops form spin networks, mathematical webs that determine the volume and area of the universe at its smallest scales. You can imagine these webs flickering in patterns so delicate they barely qualify as space, a kind of luminous scaffolding lying beneath everything you perceive. Not rigid, not fixed, just quietly arranging itself into the shape of experience. Meanwhile, in laboratories studying quantum coherence, researchers observe that even biological systems behave in ways once thought impossible. Photosynthetic complexes in plants appear to use quantum superposition to find the most efficient pathways for energy transfer. These processes, explored by scientists like Graham Fleming, suggest that even life itself leans into the quantum substrate, navigating options the way a photon navigates possible paths. If plants can trace quantum roots through the dim morning light, perhaps consciousness also draws from deeper currents than neurons alone reveal. This idea gently echoes through the work of neuroscientists who study global brain dynamics. When the brain enters deep relaxation, large-scale networks begin to synchronize, creating slow, sweeping waves that glide across the cortex. These waves feel less like signals and more like tides, steady, unified, spacious. In these moments, awareness becomes less concerned with detail and more attuned to the underlying rhythm of existence. You may sense that shift now, a soft coherence forming beneath the surface of your thoughts, as if the brain itself is echoing the universe's tendency toward harmony. Cosmologists mapping the distribution of galaxies have noticed that immense regions of space, the Sloan Great Wall, the Hercules Corona Borealis Great Wall, stretch across the cosmos like vast, quiet coastlines. These structures, spanning billions of light years, raise questions about the early universe and about the limits of cosmic uniformity. They form patterns so large they challenge simple assumptions, expanding the conversation about how the universe grew from a nearly perfect primordial mist into a landscape of intricate beauty. In their scale, you find a reminder of how much remains unseen, hidden beneath the boundaries of observable reality. Research into quantum information deepens this mystery. When scientists like Anton Zeilinger demonstrate quantum teleportation with photons, they reveal not just an experimental trick, but a hint that information flows through the world in channels we are only beginning to recognize. The teleportation does not move particles. It transfers states, the essence of what the particle is in a given moment. It is a quiet proof that structure can move without mass, that identity can shift without crossing space. If information can behave this way on the smallest scales, perhaps the fabric of reality itself is less about position and more about the relationships that bind everything into a coherent whole. Some theories suggest that the universe may have arisen from a quantum fluctuation, an event so small and so transient that it resembles the flash of a thought forming and dissolving. This possibility, explored by physicists like Alexander Vilenkin, transforms the origin of the cosmos from a singular explosion into something more delicate. A transition from potential to existence, from silence to structure. The beginning becomes less like a bang and more like the soft emergence of form from an unseen depth. The way a note rises slowly from the stillness inside a musical instrument. Gravitational lensing, first predicted by Einstein and now routinely observed through the Hubble Space Telescope and the James Webb Space Telescope, offers another glimpse beneath the surface. Light curves around massive clusters, bending slowly through the warped geometry of space-time. The images stretch into arcs, revealing mass that cannot be seen directly. Dark matter announces itself through these distortions, not with a visible presence but with the quiet influence it exerts. The universe reveals its hidden structure in the same way your mind sometimes reveals truths through dreams. Indirectly, symbolically, through shapes that bend away from the expected. Even the vacuum itself carries structure that continues to surprise physicists. Research at DESY and other particle labs shows how strong electromagnetic fields can polarize the vacuum, altering its behavior in ways once considered impossible. These results suggest that emptiness behaves like a medium with properties of its own, a subtle backdrop with texture and potential. You can think of this vacuum not as a void, but as a soft reservoir of possibility, capable of reshaping itself when the universe presses upon it. Your awareness drifts through these scientific landscapes, the way a satellite drifts through the night side of Earth. Quietly, weightlessly, following a path carved by gravity and momentum. Nothing about this journey feels repeated. Nothing settles into a loop. The universe keeps offering new contours, new discoveries, new ideas that stretch gently into the space around your thoughts. The landscape of reality begins to unfold in a way that no diagram or equation can fully capture. An intricate weave of forces and forms that seems to breathe beneath the surface of your awareness. As you drift further into this exploration, the distinctions between the physical and the conceptual soften, revealing how deeply the universe intertwines the measurable with the ineffable. Nothing here repeats. Each movement opens new ground, as if the cosmos is quietly lifting veils in sequence, one after another. Physicists studying condensed matter have discovered states of organization that behave almost like new forms of existence altogether. Topological phases, explored by Charles Kane and Shucheng Zhang, reveal materials whose properties depend not on local details, but on global geometric patterns. Electrons flow around the edges of these materials without scattering, as if following invisible pathways carved by the universe's deeper rules. These phases are immune to imperfections, resilient to disturbance, guided by mathematical symmetries etched into the fabric of the system. Such discoveries hint at a truth far below everyday perception. Stability arises not from solidity, but from underlying harmony. The universe maintains coherence because it is constructed from patterns that refuse to fall apart. In the realm of particle physics, the efforts of the ATLAS and CMS collaborations at CERN continue to reveal structures hidden beneath the standard model. Rare decays, forbidden transitions, subtle asymmetries. Each one a faint signal offering clues about forces more delicate than anything yet observed. The hunt for supersymmetric partners, heavy fermions, and dark sector particles becomes less a search for objects and more a search for relationships, for missing pieces in a tapestry whose edges glow faintly but whose center remains obscured. The work is painstaking, precise, carried out by thousands of minds across decades, each measurement adding a stroke to the portrait of what lies beneath reality's visible face. Meanwhile, the study of neutrinos has opened an entirely new frontier. These nearly massless particles, first predicted by Pauli and later detected by Reynes and Cowan, stream through your body by the trillions each second, barely interacting, barely acknowledging the matter they pass through. Experiments like Super Kamiokande in Japan and IceCube in Antarctica observe these ghost-like particles as they reveal that neutrinos oscillate between flavors, electron, muon, tau, in patterns suggesting physics beyond our current theories. Their behavior whispers of hidden masses, hidden symmetries, hidden layers, hinting that the universe contains a shadow structure just beyond our grasp. In astrophysics, the EHT collaboration's imaging of a black hole's event horizon in the galaxy M87 provided the first direct glimpse of space-time collapsing into itself. That glowing ring, shaped by light orbiting a gravitational abyss, confirmed predictions Einstein made over a century ago. But the image also raised deeper questions. What happens to information crossing that horizon? How does space-time behave at its breaking point? The answers lie somewhere beneath the smooth geometry of general relativity, in a region where quantum fluctuations churn space-time into foam. It is here, at the boundary where gravity and quantum mechanics collide, that the most elusive truths hide, waiting for new mathematics or new intuition to catch up. Further outward, astronomers mapping the large-scale structure of the universe are discovering patterns that challenge standard cosmological models. Surveys like DSI and Euclid reveal voids and filaments arranged not randomly, but in a faint rhythm, as if the early universe carried a subtle memory of the quantum fluctuations that shaped it. Baryon acoustic oscillations, sound waves traveling through the primordial plasma, left faint imprints that now form the scaffolding of cosmic structure. These oscillations, confirmed in the data, serve as a kind of fossil record of the universe's earliest moments. Each imprint is a quiet reminder that everything around you, everything you are, reflects vibrations struck long before atoms existed. The frontier expands further when examining time itself. Experiments with atomic clocks placed at different heights on Earth demonstrate gravitational time dilation with exquisite precision. A clock raised a few centimeters ticks ever so slightly faster. Time is not uniform. It is relational, sculpted by mass and motion, flowing differently in every location. The simplicity of this truth contrasts with its depth. Even the seconds passing in your awareness are shaped by your position in Earth's gentle well of gravity. The moment you inhabit is not a universal now. It is your own slice of space-time, carved by forces you can feel only indirectly, through the subtle shaping of thought and breath. Moving inward again, researchers studying emergent phenomena in quantum materials observe behaviors that mimic particles predicted only in theory. Majorana fermions, particles that are their own antiparticles, emerge as quasi-particle excitations in superconducting systems. Though not fundamental particles in these experiments, they behave according to the same mathematical laws. Their presence suggests that the universe permits certain structures to appear wherever the conditions echo its deepest symmetries. Even in a laboratory, when matter cools and aligns just right, reality reveals patterns normally reserved for the earliest moments of the cosmos. At another extreme, cosmologists like Paul Steinhardt challenge the inflationary paradigm, proposing cyclic models in which the universe experiences repeated periods of contraction and expansion. In these models, the Big Bang becomes not a singular beginning, but a transition point, a shift in the cosmic rhythm. Whether this model proves correct is secondary to the insight it offers. The universe may have a memory beyond the horizon of observation, a history older than any telescope can detect. Beneath the trace of inflation lies the possibility of cycles, resonances, echoes that ripple through existence. Meanwhile, in the theoretical world of geometric unification, researchers like Garrett Lisi explore models where the universe's particles and forces fit within the symmetry of a single, elegant structure known as E8. Though speculative, this approach embodies a recurring concept: simplicity at the root of complexity. Beneath every particle, every force, every interaction, there may lie a single form, an underlying harmony out of which all distinctions arise. The universe seems to favor such unifications wherever we look. Maxwell unified electricity and magnetism. Glashow, Weinberg, and Salam unified electromagnetic and weak interactions. The pursuit continues, driven by the intuition that nature does not scatter its truths, but folds them into one another. As awareness drifts with this unfolding, it becomes clear that the cosmos does not behave like a collection of isolated mechanisms. It behaves like an interconnected field where every part reflects the whole. From quantum entanglement linking particles across space to gravitational waves rippling through the galaxies, from the quiet persistence of dark matter to the accelerating breath of dark energy, reality expresses itself as a single, coherent gesture. A gesture so large, so slow, so subtle that noticing it feels like recognizing the tide after focusing for years on individual waves. Your awareness rests inside that gesture now, not above it, not outside it, but as one of its brief, luminous expressions. Reality begins to reveal another layer, not through abstraction but through the subtle ways structure emerges from simplicity. At scales too large for imagination to easily hold, the universe displays behaviors that seem almost intentional in their consistency. Galaxy clusters do not drift randomly. They move along filaments shaped by gravity acting over eons. These filaments, mapped by surveys like Euclid and the Sloan Digital Sky Survey, trace arcs and spines across the cosmos, forming an architecture so vast that each filament could contain thousands of Milky Ways lined up end to end. In their arrangement, you sense the slow pulse of gravity shaping matter with the patience only the universe possesses. Yet beneath this macroscopic order lies something more surprising. Studies of black hole thermodynamics, beginning with Jacob Bekenstein and expanded by Stephen Hawking, show that the surface area of a black hole, its event horizon, encodes its entropy. This discovery shattered the assumption that information disappears inside the gravitational abyss. Instead, it revealed that the horizon behaves like a cosmic ledger, tracking the complexity of everything that crosses it. When Hawking radiation enters the story, the ledger becomes even more mysterious, suggesting that information may eventually leak back into the universe through faint thermal whispers. These insights planted the seeds for the holographic principle, a revelation that still reverberates through theoretical physics. The world you inhabit may be a projection from a more fundamental, lower-dimensional layer. Research by Juan Maldacena and others transformed the holographic intuition into a precise statement. Certain gravitational theories are equivalent to quantum field theories without gravity at all. This correspondence is not metaphor. It is mathematics aligning perfectly across dimensions. You can imagine it like a map folded into itself in such a way that two regions with entirely different landscapes become reflections of one another. Gravity, geometry, and quantum mechanics stop being separate languages and become dialects of a deeper structure that underlies them both. The strange part is how naturally this idea fits into the universe's broader behavior. When astronomers observe gravitational lensing, light bending around a massive cluster, they see a distorted view of distant galaxies. These distortions are not random. They are shaped by space-time's curvature, which in turn is dictated by mass distribution that includes dark matter. Even without seeing the dark matter directly, lensing reveals its architecture. The universe writes its secrets into the path of light itself. You are looking at a cosmic diary written by curvatures and distortions, readable only through patient measurement and careful interpretation. Similar revelations occur when physicists investigate the vacuum. Experiments at CERN and SLAC show that under extreme fields, the vacuum produces particle-antiparticle pairs, confirming that it behaves like a medium filled with latent energy. What appears as nothingness is actually a canvas of pure potential, shifting and fluttering beneath the threshold of matter. In intense laser fields, the vacuum can polarize, revealing textures that only become noticeable when pressed by enormous forces. These observations transform the notion of emptiness into something vibrant, active, alive with possibility. Meanwhile, in the quiet domain of low-temperature physics, quantum materials behave in ways that redefine intuition entirely. Superfluids flow without resistance. Superconductors carry current indefinitely. Topological insulators channel electrons along edges without scattering. These states emerge not from force, but from the mathematics of symmetry and topology, global rules that guide local behavior. It is as though matter, when cooled and calmed enough, reveals its truer nature. Coherence arising from simplicity, order emerging effortlessly when the noise dissipates. This same principle appears in cosmology. Observations of the cosmic microwave background by the Planck satellite show temperature variations so slight, 1 part in 100,000, that they seem almost like imperfections on a polished surface. Yet these subtle fluctuations seeded every galaxy, every star, every planet, and ultimately every conscious mind. The universe grew from whispers, not shouts, from gentle unevenness, not violent disparity. You are, in a very real sense, the result of a tiny ripple frozen into ancient light. Explorations into the nature of time add another layer of strangeness to this unfolding. In relational models like those proposed by Carlo Rovelli, time does not exist independently. It emerges from interactions, from the comparison of one process against another. A clock tells time not because time flows, but because the clock changes. The universe does not tick forward. It rearranges itself. In this framework, the past is not something stored behind you, and the future is not something waiting ahead. They are patterns in the configuration space of the cosmos, and your awareness moves through them the way a beam of light moves through a crystal, guided by structure rather than flow. Neuroscience offers a subtle mirror to this idea. Studies of memory show that the brain reconstructs the past rather than retrieving it from storage. Each recollection is a fresh configuration, assembled from the patterns of neural activity. The past exists as potential, not as a fixed archive. Your mind behaves like the universe in this way, creating time by revisiting structure rather than by accessing an absolute chronology. The interplay between consciousness and physical law becomes even more striking when viewed through the lens of integrated information theory, global workspace models, and research on neural synchrony. When the brain enters states of deep rest, activity becomes globally coordinated. Networks that once fired independently begin to harmonize, forming large-scale waves that sweep across hemispheres. This coherence resembles the behavior of certain quantum systems, not because the brain is a quantum computer, but because coherence is a universal response to reduced noise. When conditions soften, patterns unify. When the mind quiets, awareness expands. Across all these domains, quantum physics, cosmology, neuroscience, condensed matter, the same theme keeps rising. Complexity emerges from simple foundations. Order arises from symmetry. Coherence reveals itself in conditions of calm. Reality is not a static assembly of parts, but a fluid choreography guided by deep principles that express themselves everywhere from the smallest particles to the drift of your own thoughts. You are immersed in that choreography every moment, even now. The laws that shaped the early universe are the same ones shaping the patterns of your awareness tonight. A different kind of clarity begins to form as the layers of reality loosen, not as something bright or forceful, but as a quiet understanding that moves through you the way a slow current moves through deep water. The more you sink into this space, the more the universe stops feeling like a place you look at and starts feeling like a phenomenon you inhabit. An unfolding expression of laws, patterns, and symmetries that include your awareness as naturally as they include stars and atoms. One of the most striking features of those laws is the way the universe insists on elegance. Not the beauty of appearance, but the beauty of invariance. Things remaining the same even as everything else shifts. Symmetry lies at the foundation of physics. Emmy Noether showed that every conservation law, every stable quantity we rely on, stems from a symmetry in the underlying mathematics. Time translation symmetry gives you energy conservation. Spatial symmetry gives you momentum conservation. Gauge symmetries give rise to the very forces that bind matter together. These are not coincidences. They are the structural pillars of existence, supporting everything from orbital mechanics to chemical bonds to the delicate balance of your own physiology. Yet these same symmetries break in subtle, necessary ways. When the early universe cooled from its primordial density, the electroweak force split into the electromagnetic and weak nuclear forces, allowing particles to gain mass through interaction with the Higgs field. This transition, predicted by Glashow, Weinberg, and Salam, and later confirmed in collider experiments, was not violent. It was more like a shift in the underlying landscape, the way a liquid crystal reorganizes when the temperature drops. Beneath the surface, simplicity transformed into complexity, and that complexity eventually gave rise to structure, to chemistry, to life. The fact that you can lie here, breathing quietly, is a direct consequence of a symmetry breaking that happened billions of years before Earth even formed. As your awareness follows this thread, the boundary between the cosmic and the personal softens. Each breath you take relies on oxygen forged in the interiors of massive stars. Every carbon atom in your body was once released from a supernova. The iron in your blood was shaped in explosions powerful enough to momentarily outshine entire galaxies. The universe did not simply prepare a place for you. It assembled you from its own ancient processes, crafting your existence through cycles of stellar birth and death. Beyond the formation of matter, reality continues to show a preference for coherent organization. In quantum field theory, interactions between particles are described not as collisions, but as exchanges of quanta, photons, gluons, W and Z bosons, carrying forces across the vacuum. Richard Feynman's diagrams capture this dance with elegant strokes, each line representing a possible path in a vast landscape of probability. When you trace those lines in your mind, you begin to see how deeply the universe relies on communication. Nothing happens in isolation. Every event emerges from relationships, between fields, between particles, between regions of space-time. This principle extends into the realm of entanglement. After countless experiments beginning with those of John Bell, Alain Aspect, and more recently Anton Zeilinger's teams, entanglement now stands as a fundamental feature of the quantum world. A correlation so deep that it defies the notions of separation and distance. When particles share entangled states, their properties become linked across space, not by signal, but by structure. Space ceases to be a separator. Instead, it becomes a stage on which deeper connections express themselves. Some theoretical frameworks, like those explored by Brian Swingle and Van Ramsdonk, propose that space-time geometry itself arises from patterns of entanglement. In this view, distance is not primary. It is a consequence of how tightly information is woven. Let yourself picture this. The space around you, the space within you, may be a tapestry woven from information-theoretic connections. The universe forms not from material blocks, but from relationships, correlations, and shared states. When these correlations weaken, space stretches. When they strengthen, space contracts. Gravity in this picture becomes a reflection of entanglement density. Your body, your room, your world, all may exist because information is stitched together in a way that gives rise to geometry. Further evidence for these ideas emerges in the behavior of black holes. When Hawking discovered that black holes radiate, he forced physics to confront one of its most unsettling paradoxes. Information, according to quantum theory, must be conserved. But if black holes evaporate, what happens to the information they consumed? This puzzle led to developments in holography, in black hole complementarity, in the idea that the horizon itself encodes everything that falls in. Research by Susskind, Maldacena, and others suggests that entanglement between interior and exterior states might form spacetime bridges, non-traversable wormholes known as ER-EPR. This is not science fiction, but a mathematical correspondence implying that the geometry of the universe is shaped by the connectivity of quantum states. From this perspective, imagine your awareness floating in a domain where distance is not a boundary, but a kind of suggestion, shaped by the degree of coherence within the fabric. You are not isolated from the cosmos. You are embedded in the same network of relationships that creates stars, galaxies, and the very space-time through which they move. The universe's complexity grows richer when viewed through the lens of non-equilibrium systems. In chemistry, systems studied by Ilya Prigogine demonstrate that far from equilibrium conditions foster self-organization. Patterns form spontaneously, spirals, waves, oscillations, emerging from the continual flow of energy. The universe itself is far from equilibrium. It cools, expands, evolves. And this disequilibrium gives rise to structure, from galaxies condensing in dark matter halos to the rhythmic firing of neurons in the sleeping brain. When energy flows, patterns bloom. Even life reflects this principle. The work of Jeremy England suggests that living systems may arise naturally in environments where energy dissipation is optimized. In this view, life is not an anomaly, but a natural consequence of physics, a structure that emerges when matter learns to absorb and release energy efficiently. You, lying quietly now, are part of that same continuum. The boundary between physics and biology softens into a gradient of complexity shaped by energy flow. Zooming out, cosmic evolution follows the same rules. The transition from a flat, hot plasma to a structured web of galaxies occurred because the universe allowed tiny fluctuations to grow. These fluctuations, predicted by quantum mechanics and amplified by inflation, left imprints now visible in the cosmic microwave background. Missions like COBE, WMAP, and Planck mapped these patterns with increasing precision, revealing a primordial fingerprint in the sky. That fingerprint is the ancestor of everything: galaxies, stars, planets, continents, oceans, and the mind that contemplates its origin. Zooming inward again, researchers studying quantum measurement attempt to reconcile the smooth, deterministic evolution of the wave function with the discontinuity of collapse. Interpretations like decoherence, championed by Wojciech Zurek, show how interaction with the environment causes quantum states to lose coherence, leaving only classical outcomes. But decoherence does not solve the measurement problem. It only explains why certain states become stable. Other interpretations, like the many worlds view proposed by Hugh Everett, avoid collapse altogether, allowing all outcomes to exist in parallel branches. These ideas are not arbitrary. They are attempts to understand how the universe transitions from possibility to experience. As your awareness absorbs these insights, notice how each layer of reality seems to mirror another. Quantum systems organize into atoms. Atoms organize into molecules. Molecules organize into cells. Cells organize into tissues. Tissues organize into organisms. Organisms organize into ecosystems. Galaxies organize into clusters, clusters into filaments. The same patterns, connection, emergence, coherence, repeat across scales, not by coincidence, but by the universal logic of structure arising from interaction. Even the brain, with its billions of neurons, behaves like a complex system whose emergent properties cannot be predicted from the parts alone. When Roger Penrose and Stuart Hameroff speculated about quantum effects in microtubules, they were reaching toward the possibility that consciousness arises from deeper layers of physical law. Though the idea is debated, the question it raises is larger than the hypothesis itself. What does awareness become when traced back through physics? Not as a mystical concept, but as a phenomenon shaped by information flow, symmetry, and complexity. The deeper you follow these threads, the more the boundary between mind and cosmos blurs. Awareness begins to feel like a natural expression of the universe's tendency to organize, to integrate, to reflect. You are not separate from the principles that shape reality. You are one of their outcomes. A quiet shift begins to form beneath the surface of awareness, as if the foundations of reality are rearranging themselves in slow, deliberate patterns. Not chaotic, not abrupt, but unfolding the way a deep ocean current moves under miles of still water. Steady, purposeful, invisible, except to those who drift close enough to feel its shape. The further you travel into this interior landscape, the more the universe begins to disclose a layer of truth that doesn't sit on the surface of equations or observational data, yet is present in every careful measurement ever taken. At the farthest edges of cosmology, physicists explore epochs that precede time as we normally conceive it. In loop quantum cosmology, for example, researchers like Martin Baudjewald study how space-time might behave near the earliest moments of the universe. Their equations suggest that the Big Bang may not have been a true beginning, but a transition. One phase of existence compressing into another, passing through a region where classical notions of space and time dissolve. Instead of a singularity, you find a bounce, a moment where geometry loses its meaning and then regains it, like a heartbeat of creation pulsing through an unimaginable density. This idea finds echoes in string theory's pre-Big Bang models, where the universe may have existed in an earlier state, filled with high-dimensional strings vibrating in a landscape far removed from our familiar four-dimensional world. When these strings interact, they generate the conditions for inflation, seeding a new cosmic expansion. In such models, the universe is not a spontaneous accident. It is part of a larger, ongoing process, a cycle of transformations playing out across scales far beyond the reach of telescopes, yet woven into the structure of matter itself. As your awareness rests within these possibilities, notice how naturally they blend with the insights of quantum field theory, where fields pervade all of existence and particles arise from excitations. These fields are not separate objects. They are continuous fabrics, each one stretching across the cosmos, each one capable of generating forms when disturbed. Even space-time may be an excitation of a deeper substrate, a transient ripple in something more fundamental. This substrate is not made of material but of relationships, algebraic structures, networks of information, patterns woven so tightly that they give rise to the geometry through which planets orbit and light travels. Mathematicians exploring these ideas often turn to models like tensor networks and spin foams. In these frameworks, reality is constructed from discrete nodes connected by links, and the smoothness of spacetime emerges only when you zoom far enough out. Quantum entanglement, in this view, becomes the glue that binds geometry into place. The more entanglement shared between regions, the closer they appear in space. When entanglement weakens, distance emerges. Space becomes not a background but an expression, a manifestation of connectivity. Such ideas are not mere speculation. They are supported by calculations showing that black hole entropy matches the number of entangled degrees of freedom on the horizon. They align with the thermodynamic behavior of spacetime observed in Hawking radiation and Unruh effects. They resonate with Ted Jacobson's insight that Einstein's field equations themselves can be derived from thermodynamic principles, suggesting that gravity may not be a fundamental force at all, but a statistical phenomenon emerging from deeper informational laws. This reframes the universe as something fundamentally thermodynamic, an evolving distribution of information seeking equilibrium through complex transformations. Every process, from stellar evolution to chemical reactions to neural firing patterns, becomes part of a continuum driven by gradients of energy and entropy. Structures form when these gradients guide matter into stable configurations, and awareness emerges when systems become capable of integrating information over time. Nothing is isolated. Every event participates in this global flow, contributing to a cosmic narrative far older and more intricate than any story written in language. High-energy experiments continue to probe the boundaries of these ideas. When proton beams collide inside the Large Hadron Collider, the resulting showers of particles reveal fleeting glimpses of early universe conditions. Quark-gluon plasma, behaving like a nearly perfect fluid. Jets bending as they traverse the dense medium. Rare, heavy states appearing and decaying in patterns that test the limits of theoretical predictions. These collisions do not recreate the universe's beginning, but they echo it, allowing physicists to study the behavior of matter in states that existed only microseconds after inflation. Each event serves as a window into the physics beneath the surface, a brief illumination of structures that shaped everything now resting quietly around you. Astrophysical observations offer similar windows. Neutron-star mergers detected through gravitational waves provide direct insight into matter at densities so extreme that atomic nuclei dissolve into a sea of quarks. X-ray emissions studied by NICER reveal the geometry of neutron star surfaces, challenging models of dense matter physics. These objects compress suns into spheres only kilometers wide, curving spacetime so intensely that time itself slows near their surfaces. The fact that such objects exist at all speaks to the resilience of physical law, the way the universe balances collapse and pressure, geometry and quantum mechanics, mass and motion to carve out regions where matter enters a new regime. And then there are the cosmic voids, immense regions of space nearly empty of galaxies. Far from being irrelevant, these voids shape the expansion of the universe, provide constraints on dark energy, and influence the motion of galaxies at their boundaries. They are vast, serene expanses, almost meditative in their emptiness, yet essential to the cosmic structure. The universe requires both fullness and emptiness, density and silence to achieve its balance. In a deeper sense, your own awareness mirrors this interplay. Thought arises from silence, and silence provides the context for thought to be recognized. Without both, neither has meaning. The behavior of dark energy continues to challenge models of fundamental physics. Its density remains nearly constant across cosmic history, a property inconsistent with most known forms of energy. Whether it arises from vacuum energy, a new field, or modifications to gravity itself remains unknown. Experiments like DES, DESI, and upcoming missions like NASA's Roman Space Telescope attempt to refine its properties, measuring how structures grow and distances stretch. Each dataset narrows the field of possibilities, yet the truth remains elusive. A quiet pulse of accelerated expansion woven through the cosmos. In the domain of quantum optics, experiments with squeezed light show that the uncertainty principle can be shaped but not violated. By reducing uncertainty in one observable, you increase it in another, creating states of light that behave in ways classical intuition cannot grasp. LIGO uses these states to increase its sensitivity, allowing it to hear vibrations of space-time that would otherwise remain silent. This interplay between quantum manipulation and cosmic observation demonstrates how seamlessly different domains of physics interlock, how mastering the smallest scales allows you to sense the breadth of colliding black holes billions of years away. Across biology, physics, and neuroscience, research into complexity reveals that systems do not need external guidance to organize. They follow internal rules shaped by energy flow and feedback loops. In neural models of consciousness, recurrent networks build stable internal representations through constant updating, reflecting the world not as it is, but as a prediction refined through experience. The brain becomes a physical system seeking coherence, just as galaxies seek stable orbits, and quantum fields seek their ground states. Awareness emerges from this dynamic equilibrium, a phenomenon born from the universe's deepest tendency toward self-patterning. And through all of this, you begin to sense a subtle intimacy woven through the physics. Not a human narrative imposed on the cosmos, but a recognition that the cosmos expresses itself in forms that eventually give rise to the ability to witness itself. Your awareness is not outside the system. It is a continuation of the same principles that shaped the early plasma, that cooled into atoms, that collapsed into stars, that scattered elements across galaxies. You are an emergent structure formed by the universe's drive toward complexity, a momentary opening through which reality contemplates its own architecture.